Okay, 4.5, this is a one problem assignment. Now, so far, you don't need to write this. We have solved two types of maximum problems. There's how to maximize the area given the perimeter, okay? So that's area's length times width. Area turns into y. Then if I tell you you have the perimeter is 80, okay? To just find what L and W, you have to just a single L, single W, so you cut everything in half. 40, okay? So I'll pick a value for X, okay? Be L. So W, if L is X, I'd minus X, and W is equal to 40 minus X, okay? Then you multiply that out, and it's always opposite of B divided by 2A, replace, and that tells you your maximum area. Okay, then we did the gravity, okay? That's when you draw out your blanks, because gravity has a number that's not even in the problem. Gravity, velocity, that's always, you can tell what your velocity is by the word per. So that might be 80, and then your starting height's 3. That's opposite of B, 2A. Now we're going to learn our third and kind of final type of application piece, and it's maximum revenue. Okay. Now I'm going to do an illustration here before I start the process. Okay. An online store sells 4,000 songs when it charges $1 per song. For each 5-cent increase in price, 80 fewer songs are sold. Find how the store can maximize revenue. Okay, so the word, go on your paper, okay? The word maximize means, and down here, you're going to put maximum revenue. Okay, and you need to find the maximum point. Of course, we're going to need to generate an equation to find this, but it'll be opposite of B divided by 2 times A, and finding the Y is simply substitute for X. Now let's leave off on that part, okay? And then we'll come back to it. Now I could actually solve this problem just using some street math, but it would take a long time on some of them. So he starts selling the songs for $1. He sells a quantity of 4,000. So the revenue is taking that, the price times the number of items. That's 4,000. $4,000. Now, if he raises a price by 5 cents, he's now charging $1.05. But since he upped the price, less people are going to want to buy the songs. 80 fewer, okay? So if every time I raise that 5, that goes down by 80, so it's going to be $3,920. So I take $1.05 times $3,920. And I come up with 4,116. So the revenue went up. So that's good. I made a good business decision. Now if I do it again, up by 10 cents, and that drops, that'd be 3,840. Okay. So $1.10 times 3,840, it goes up again to 4,224. So again, another smart business move because it went up. Now, if I keep doing that forever, eventually this drops to 0. And anything times 0 is 0. So there is a high point we have to find. Now, we can find it by doing that, but that problem is going to take at least probably 30 minutes. Now, let's generate a revenue equation. What was I just doing to find those revenues? I was taking the price I was charging times the number of items that I was able to sell. Price of the items times the number of items sold. I was multiplying there. Now, revenue is going to become Y, okay? Now, let's talk about the money. You're not going to just put a number, you're going to write an expression. You start at $1. Don't put X on the dollar. I know it says per song, but you don't do that. The dollar is your starting price. Then what was I doing? I was adding 5 cents, okay? But I was adding it over and over and over. I don't know how many times I would have to add it to hit that high point, so that's where the X goes, okay? Then in the problem, cross out $1.05. Those are, this is for money, okay? Money goes here. Now the number of items, we started at 4,000. And if this is plus, this is minus. If that would have been minus, that would have been plus. Because if I raise the price, less people buy because it's more expensive. If I would drop the price, more people buy because it's less expensive. So if that's plus, they have to run counter to one another. And I was subtracting 80 all the way down that table. Don't know how many times, it's however many. So these are both X's. Now, we don't have an ABC yet. So what I'm going to do is I'm going to get my own ABC by using the FOIL method. Okay, so I take 1 times 4,000 and then 1 times negative 80x. Okay, so I distribute 1 to each one of those. Then I distribute 0.05x to 4,000 and 0.05x to negative 80x. Now I find the products. There's no x's there, that'd be 4,000. There's an x, 1 times negative 80 is negative 80. There's an x, 0.05 times 4,000 is going to be 200. Okay, positive 200. X times x, that's going to be an x to the second, and then 0.05 times negative 80 is negative 4. So I want you to look through those products. What's your x to the second? It's negative 4. That's our A. What's your x? Negative 80 and 200. Add those, it's 120. That's your B. You add those. And then 4,000 is your constant. That's your C, but you really don't need to label C. Now I'm in like Flynn, okay? So, negative 120, opposite of B, and then 2 times negative 4. So that's negative 8. Then I divide, I get 15. Now what does that represent? 15 is how many rows I would have, okay? I would have to do this 15 times. I've only done it twice there, okay? 15, what we call price changes. I change a price 15 times. And then Y is your money. To find it, you plug 15 in for X. $4,900. Okay, that's the most revenue you could achieve. You would do 15 rows here and get to $4,900 with your maximum. Then after you got to 4,900 here, it would start declining. Okay. All right, do another one. Actually, you have 2 problems, my bad. Okay, an electronics store sells about 70 of a new model of digital camera at a price of $320 each. For each $20 decrease in price, 5 more cameras are sold. Find how the store can maximize revenue. Okay, so any maximum, we want to set this up because I know I have to apply the formula opposite of B divided by 2 times A. And then this is sub for X. Okay, revenue, it's the money I charge times the number of items, okay? Like area's length times width. The gravity already starts with the blank x squared, blank x, and blank. Revenue is money times items. So this becomes Y, and then I write expressions for the dollars and the items. So that's going to be your money, okay? Okay, now my money. So only money amounts go in this first parentheses. You should not be putting 70 and 5 in there. You got to have money. Pre-20 and 20. So it's $320. Then we're decreasing the price here, so minus 20x. So I would start at 300, then start minus. I'd start at 300 here, then I'd start minusing 20. Well, then the other one's going to be up. So 75 more, so 70 plus 5x. And x here is the price changes. Okay, so in the area, let's refer back. Area, the x, y at the maximum. The x is one of the 2 dimensions, and then y is the area. On the gravity, X is the number of seconds at any specific time, Y is the number of feet. Now here, X is going to be how many times we would change the price, and Y would be the maximum revenue I get by changing the price, the revenue I get. Well, I need to actually find this product using the FOIL method, okay? So that 20 is negative, so here are my pluses, so I have to distribute 320 to 70 and then to 5x. Then we need to distribute the negative 20x to 70 and then to 5x. Remember the 20x is negative, you can't lose sight of that, okay? And then 70, 5x. If you just put 20 down, you're going to get a screwed up answer. So 320 multiplied by 70 is 22,400. 320 times 5 is x, and then 1,600. Here we have our x factor, and then negative 20 times 70 is going to be negative 1,400. And then here we're going to have x to the second, okay? Negative 20 times 5 is negative 100. Okay, now we can line up our spaces, and then the ABC is found. So x squared is your negative 100. X, I combine these two by adding 1,600 and negative 1,400 is 200, and that's your B. C is 22,400. Okay, so opposite of B, you're going to have negative 200, and on bottom you're going to have the product of 2 times negative 100. So you divide that, you get 1. So there's only going to be one price change before maximum revenue is reached. So really the table, I would have found it pretty quickly. So negative 100. See, on that first one, there would have been 15 rows. This one, well, there would have been the first row, okay? Actually, you'd have had to make 16 rows to see that it dropped. But this is better strategy, okay? $22,500. So one price change is all you would do to get $22,500. So let's prove one price change isn't very hard to figure out. So he decreases it by 20, so that'd be $300, and he'd sell 75 cameras. So $22,500. Now if he did it again and decreased it by $20, it'd be $280. And then times 80, now it's went back down, so that's why you want to stop after just one price change on that. Okay, next example. A video store sells about 150 DVDs at a price of $20 each. The owner estimates that for each $1 decrease in price, 25 more DVDs will be sold. What's the maximum revenue that can be raised? Again, anytime I'm finding a maximum value, I'm going to need to make this, okay? In a story, within the context of a story problem, opposite of B divided by 2 times A, and then Y is just substitute for X. Alright, so let's, what situation we dealing with? Certainly not area, certainly not gravity, we're dealing with revenue. To find the revenue, you take the money you charge for a certain item times the number of items you sell. So R becomes Y. Then we write an expression for each factor. Okay, so dollars, only dollars belong in here. Well, we start at $20. $20. Then we decrease by $1. Now we decrease by $1 multiple times, so X. Now the items, in this case DVDs, you start at 150. Now if you're decreasing here, you're increasing here. 25 more, but that happens multiple times, so that will be X. Now I got to get an ABC out of that, and I can find it if I just find the product using the FOIL method. So make that 1 plus negative, so you can see where the plus signs lie. So I distribute 20 to 150 and 20 to 25x. Then I follow suit with the negative 1x. Don't forget that it's negative. I distribute it to the same two terms. So 20 times 150 is 3,000. You're going to put x. 20 times 25 is 500. Then you put x. Negative 1 times 150 is negative 150. And then you're going to put x to the second because you have two, but each factor has x. Negative 1 times 25 is negative 25. So x to the second, you would have your negative 25. That's your a. Now for x, you will need to combine the like terms of 500 and negative 150. That would make 350, and that would be your b. And then your constant's 3,000, which is your c. So opposite of b is negative 350. 2 times negative 25 is negative 50. Then we divide and we get 7. Remember, that's price changes. Okay, sub for x, so you replace here, and the y is your money that you raise. Okay. So I take negative 25 times 7 to the second plus 350 times 7 plus 3,000. 4,225. So you put that down there as your maximum revenue. You get that from 7 price changes. Alright, last example. A go-kart track has 380 racers and charges each racer $35 to race. The owner estimates there will be 20 more racers for every $1 decrease in price per racer. How can the owner of the go-kart track maximize weekly revenue? So we want to find his maximum revenue. As far as how he can do it, well, that's measured by price changes. Okay, x will be found by applying our vertex formula in a standard form quadratic equation. Opposite of b divided by 2 times a, and y is found by replacing x. Okay, we're talking in context of revenue. Revenue, maximum revenue. Revenue is taking our money times the number of items. So revenue is going to be our y. Okay. X will be in here somewhere. Money, only money amounts go in the first parentheses. Listen, only circle your 2 money amounts. Circle them. You start at 35, then you're decreasing it by 1. So 35 minus 1. I'm decreasing it multiple times by 1, I think. So x. And x is the price changes. Price changes. Okay. Then your items, starting at 380. Now if I'm minusing here, I would add here by 20x. Now I need to apply the FOIL distributive property, whatever you want to call it, okay? But it's binomial by binomial. That's 2 terms, that's 2 terms. You apply the FOIL method. So I distribute 35 to 380, then to 20x. Okay, then I distribute negative 1x to 380, then to 20x. Okay, and I find my products. 35 times 380, 13,300. Okay, we're going to have x in the next product, 35 times 2,700. Going to have x in the next product, that's a negative 380. And we're going to have x to the second in the final product, that's going to be negative 20. Okay. Okay, now you line that up and you'll have your A, your B, and your C. But you really don't need the C. It needs to be there. Okay, x squared would be the negative 20. What has x's? Well, combine 70, 100, and negative 380. That would be 320. Then I have 13,300. Now I can go up here. Opposite of B is going to be negative 320. And in the denominator, we will take 2 times negative 20. negative 40. Then I divide those and I get 8. 8 price changes. Now the money that's gonna take me to the revenue, I just substitute the 8 for the x. So negative 20 times 8 to the second plus 320 times 8 plus 13,300, 14,580. Okay, and that's your maximum revenue. Okay, you have 2 problems to do.